Hello, welcome back to my channel. We are here with yet another video of the binary tree series. Today we will be solving this problem, find the lowest common ancestor of a binary tree. Now, what do you mean by the word ancestor? Uh, Take an example of your family tree. In your family, your parent, your grandparents, your great grandparents are all your ancestors, right? So, in a binary tree, consider this node. So for this node, what are all the ancestors? Its parent, its grandparents, right? So basically for 6 the ancestors would be 5 3. Okay, for 4 the ancestors would be 2 5 and 3. So technically this includes all the nodes from root till that particular node. If we want to find the ancestors of 8, so we will consider all the nodes that comes in the path of root till 8, right? 3 to 8. So for 8 the ancestors would be 1 3. Okay, 1 3. Now how do we find the lowest common ancestor of two nodes? Okay, lowest common ancestor of two nodes. Let's just try to find the LCA of 6 and 4. Okay, now if we look at 6, the path from root to 6 contains what all nodes? For 6 the path will contain 3 5 6, right? And for 4 the path till here, the path from root till 4 contains what all elements? It contains 3 5 2 and 4, right? Now what is the lowest common ancestor? The lowest common ancestor is the common ancestor between 6 and 4, which is also at the deepest level in the tree, or the farthest node from the root. Okay, now let us check. So if we check one by one, 3 and 3, yes, common. We again go further right. 5 5, yes, common. We again go right. 6 2, is it common? No, we stop here. We stop here and we take 5 as our answer. Let us take another example. Let us try to find the LCA of 7 and 8. 7 and 8. So for 7, what all nodes? For 7, what all nodes are there from root to 7? What all node comes in the path of root to 7? So this is the path, right? So we have 3 5 2 7, right? And for 8, what all nodes are there? We have 3 1 8, right? 3 1 8. So if we traverse, yeah, this is common, 3 is common, we go further right, we try to find the deepest common node. 5 1, no, it's not matching, we stop here and we take 3 as our answer. So our answer is 3. This is the only first and only intersection and common ancestor between 7 and 8, right? Between 7 and 8. Let us try to find the LCA of 5 and 4, of 5 and 4. So this path between root till 5, and for 4 we have, for 4 the path from 4 till root is this. So this is the point of intersection. Visually we can see this is the point of intersection. Now let us write down the nodes in the path of 5 and 4 individually. So from 5 till its root, the path contains nodes 3 and 5. For 4, the path from its root to 4 contains 3 5 2 4. 3 5 2 4. This is matching? Yes. We go further deep. Is this matching? Yes. Yeah, we go further deep. This has 2, but here we have nothing, so this is not matching. We stop here and we take 5 as our lowest common ancestor. We take 5 as our lowest common ancestor. Note that a node is allowed to be an ancestor of itself. So this is another binary tree. Let us try to find the LCA of nodes 7 and 8. Okay, 7 and 8. Now the path from root to 7 includes 10 6 8 7, right? And the path from 8 root to 8 includes 10 6 8. Okay, so now if we check from the root, this is common, yes, 10 is common, we go further deep. 6 is common, yes, 6 is common, we go further deep. Is 8 common? Yes, 8 is also common, we go further deep. 7 is there and here we have no element, so this is not matching, so we stop here and we take the deepest common element. This is the lowest common ancestor for 7 and 8. Now let us try another example. Let us try to find the LCA of 3 and 7. Let us try to find the LCA of 3 and 7. So for 3 and 7, yeah, here we have 3. So the path from root to 3, includes 10, 6, 3, right? And for 7, as we already know, the path is 10, 6, 8, 7. Okay, now we start checking what are the matching ancestors. Is 10 matching? Yes, 10 is matching. We go further deep. Is 6 matching? Yes, 6 is matching. We go further deep. Is 3 and 8 matching? No. No, we stop here and we take 6 as our answer. So 6 is the lowest common ancestor for 3 and 7. So basically, if we draw a line from root to 3 and if we draw another line from root to 7, the lowest point of intersection should be our answer. The lowest point of intersection here is 6. So 6 is our answer. Now, I hope it is pretty clear by now. Now let's see how we can solve it. The approach will be to find all the elements, okay, from root till that node and store it in a data structure. Okay, store it in a, so suppose for this, right, for 7 we store all the elements from root till 7 in a data structure, right? And for 8 also we store all the elements from root 8 in another data structure. And now we one by one we traverse through this data structures and we find the deepest common element, right? We find the deepest common element and return our answer. So what is the time complexity and space complexity for this? So this approach will take additional space of the arrays, right? It depends on the maximum path from uh, root to that particular node. So for each pair we have to find and store it in a data structure, and then for each iteration, like for 7, from 10 till 7 we have to do one iteration or recursive call, which the worst case complexity could be O of n, and similarly for 8 also it will be O of n. So there will be 2 calls, right? Now instead of finding full paths for both nodes, right, we can solve this in a single search of the tree. The trick is to let recursion itself find where the 2 nodes meet. Okay, now let's take an example to understand this easily. Okay, let us try to find the LCA of 6 and 4. So I've just taken a normal naming for this two nodes to help understand the solution. Now when we are standing at a node, okay, if the node is null, there is nothing here, so we simply return a null. If the node is P or Q, then we have found one of our targets, so we directly return that node. Okay, so we directly return that node. Now I'll search in the left subtree and in the right subtree. Okay, I'll search in the left subtree and right subtree. If the left side finds something and the right side finds something, that means this is the spot where the paths of P and Q split. Okay, in this example this will be the spot where underneath this I'll find something from the left and I'll find something from the right as well. Okay, at this spot at 5, the paths of 6 and 4 has split, so 5 is the lowest common ancestor. So if only one side finds something, that means both nodes are somewhere under that side, so I just bubble up that result. Okay, I'll just bubble up that result. If neither side finds anything, I simply return null. Okay, I simply return null in that case. Now let us try to find the LCA with our set conditions here. Okay, we are at 3. Okay, is 3 equal to P or Q? No, we recursively go to the left and right. So first we'll go to left. We are at 5. Is 5 equal to P or Q? No, 5 does not match our targets, so we go further. We further recursively go deep. We go to left. We are at 6. Is 6 equal to our targets? Yes, 6 is equals to P. We simply return 6 from here, right? Now we go to the right side of 5. We go to the right side of 5. We are at 2. Is 2 any of our targets? No. We go to the left of 2. 7. Is 7 in our targets? No, 7 is not. We go to the left of 7, but left of 7 is null. In case of null, we will simply return null. So from here also we will return null. So 7 got null from its left and null from its right. Okay, so if neither side finds anything, we are returning null. So 7, from 7 we are returning null to 2. Now we go to the right side of 2. We have 4 here. Is 4 one of our targets? Yes, yes, 4 is equals to q. So we found our another target. So we return 4 from 2. We return 4 from 2. Now 2 has null got 2 now 2 has got null from its left and 2 has got 4 from its right, right? That means, so in that case we will just bubble up that result. Okay, now we are at 5. So 5 got 6 from its left and 4 from its right. So both the left and the right child of 5 has returned not non-null values. That means 5 is the lowest common ancestors. We have got our lowest common ancestor here. So we will simply return the node which is 5. We'll simply return the node which is 5. Now we come to the right child of 3. So we have 1 here. 1 does not match 6 or 4 or p or q. So we go further deep. We are at 9. So 9 is the leaf child, so it will get null from both left and right childs. So 9 is also not equal to p or q. So from 9 we will return null to 1. Similarly, from 8 we'll return null to 1. So 1 got a null from its left child and null from its right child. So we'll simply return null. So now at 3 we have 5 from its left child and null from its right child. In that case, what do? We simply bubble up this result. This means that both the targets are in the left subtree of 3. So in that case, we simply bubble up that result, which is 5. So 3 returns 5 and our answer for this LCA is 5. Okay. So the basic algorithm is, suppose we are at this node. So we first check node equals to null or node equals to p, or if node equals to q. If any of this condition satisfies, then we simply return the node. We do not traverse any further, we simply return the node. Else what do? We find left, which is equals to LCA of node dot left, right? We traverse to the left subtree, and we traverse to the right subtree, LCA of node dot right. Okay, so we have to find the LCA of 6 and 9. So we are at 3. 3 does not satisfy this condition 1. So we go to left. We come here, we go to left. 5 also does not satisfy condition 1. So we go further left. We are at 6. Now 6 satisfies this condition, right? So 6 is equals to our p. Suppose this is p, this is q. So we simply return 6 from here. Now we are at 5 again, 5, and from 5 we go to the right subtree. So we are at 2. 2 does not satisfy condition 1. So we go further down. We are at 9. Is 9 satisfying condition? Yes, 9 is equals to q. So we simply return 9 from here. Now we go to the right. Now we go to the right of 2. Right of 2 is null. Node equals to null. It satisfies this condition. So we simply return null from here. So 2 has got 9 from its left child and null from its right child. So what do we do in this case? As I have explained previously, in this case, this means that we have some target which is in the left subtree of 2, since from the right side we are getting a null. So we will bubble up this value. We will return 9 from 2. So the condition would be, if our right equals to null, then we return left. Similarly, if left is null, we simply return right. Note, if one of left or right is null, then only we return the other value. We return the other value. Now comes this condition. Where this 5 is getting 6 from left child and 9 from right child. In this case, it is getting non-null values. It is from both his left and right children. So in that case, we have found our lowest common ancestor, and we will simply return that particular node. So we will return 5. So what will be the condition? So we have already seen, if right is null, we are returning left. If left is null, we are returning right. Else, what if neither right or left is null? In that case, we will simply return the root. We'll simply return the node. Okay, we'll simply return the current node. 5 has returned its value 5. Now we go to the right side of 3. Which is 1. 1 does not satisfy condition 1. Traverse to the left of 1, we are at 7. 7 also does not satisfy this condition. We traverse to the left of 7. 7 is null. Left of 7 is null. It satisfies this condition. So from left, 7 gets a null. We come to the right side. Right child, we have 4. We come to the right of 7, we have 4. 4 does not satisfy condition 1, so we go to the left and right of 4. From both we get a null, so 4 returns null to 7, right? Now 7 gets null from its left and null from its right, so 7 simply returns null. 7 simply returns null. Okay, now we go to the right of 1, we come at 8. From 8 also we will not get anything, we'll get a null. Okay, now both left and right is null, both left and right of 1 is null, so we will simply return null from 1. Now we are at 3. Now we are at 3. So tell me what condition will satisfy? So 3 got a 5 from left and 3 got a null from right, so this is the condition that is satisfied. So right is null, right? So in that case it will simply return 5. It will return whatever it got from the left child, right? So 5 is our answer. This is the algorithm. Now let us look at the code. Here is the solution. Let us quickly take a look at the solution. This is pretty straightforward. If root is null or root equals to p or root is equals to q, we simply return the root. We simply return the root. Otherwise will traverse to the left subtree and will traverse to the right subtree. Okay, if left is null, right, then we return the right. Okay, if right is null, we return the left, and if neither is null, then we have got our ancestor, we have got our lowest common ancestors, and we return the root. Okay, thank you so much for watching. Please do like, share and subscribe. Thank you so much.